Jeff,
Yep.
give me the A and the O of one of your triangles.
30 centimeters.
30 centimeters,
38.
38 centimeters. Okay? So that's one of their triangles. This is 30, this is 38. For another one of your triangles, Gabby, give me the A.
38 millimeters.
Stop. Is there anybody that can tell me what the O is of this triangle? How would you figure it out?
You take 38 divided by 38.
Good. A over O, right? So we've got the A on the top, the O on the bottom. This is the little triangle, this is the big triangle. The A of the little triangle is 30. The O of the little triangle is 38. For the big triangle, what do we have?
38.
We have the 38. So how would you figure out that number? Cross multiply and divide. What do you get? 40 what?
8.13.
Gabby, is that correct?
I got 47.5.
40 what?
7.5.
47.5. We're within range, right? It's pretty close. What do you think would be some of the reasons why we could be off a little bit? Rulers weren't real accurate. Measuring guy wasn't real accurate. Or, probably the biggest one is that cutter guy wasn't accurate. Okay, I was doing this on my table saw at home. Look I've got all 10 of my fingers. So that's step one, is make sure that you don't cut any of them off. Okay, so I could have made a mistake when I was cutting the triangles. Alright, now, I want you to do 30 divided by 38. What do you get for a decimal there? What?
0.79. 0.79.
0.79? 0.789, is that what you
Yeah.
said? 0.79, so we rounded it as 0.79. Okay? You've got another triangle. What was the third triangle of your group? Give me the A of the third triangle.
The A is 7.5 centimeters.
7.5. Okay, so I'm going to change this problem slightly. Instead of writing 30 over 38, I'm going to just write 0.79 for this side. Everybody okay with that? I simplified the math. And you have 7.5 is the top, and you're looking for the opposite. I'll put a question mark there. You're looking for the question mark. So what would you press in your calculator? 7.5 times 0.79. Okay? And what'd you get? What?
5.93.
I have 9.
You're supposed to divide by it.
You should have divided. I'm sorry. Divide by 0.79. My fault. 9 point. What?
09.
Hey, why did my quality control stop me right there?
Because it was less than.
Because it was smaller, right? I knew I must have made a mistake. And so I should have divided by 0.79 rather than multiplied by 0.79. Okay, so if the number is on top, I should have divided by it, and I multiplied by it. Okay, so 9.48. Next. Measure the 3 angles of your triangle. Each one of you has a protractor. Measure the 3 angles of your triangle.
The bottom one.
Some of those are pretty hard to measure, aren't they? That one that you've got, Nicole, is pretty hard, isn't it? Because you have to almost extend the length of the side. Terry's is pretty easy because her triangle is big enough that you can see the whole thing. And plus you can't see the numbers on that one. I've got an extra one someplace. Okay, Tyler, do you have all three of yours measured?
No.
Just about.
Did I only give you guys one protractor for your group?
Yeah, that's how we're working.
Oh, that was kind of
I mean,
my
we're
fault.
getting there, don't worry.
We didn't give you enough equipment
This one's
to...
60.
Oh, here we've got extra equipment, thanks, Josh.
The other maybe.
Close enough? Are they close enough? So, yeah,
23, 68, 90.
that's close. 23 and 68 is 91, right? So you're within 1 degree. All right. Now, of your littlest triangle, Tia, your littlest triangle, give me the three angles.
23, 68, 90.
Okay. For the rest of you, looking at the diagram of their triangle, can you tell where those three measures are going to go? I just listed the three measures. You can't tell. Heather,
What?
how do you know? Which one goes where? You said you do.
90 goes at the right angle.
90 goes there.
Yeah, 23 goes to the left side. And then the other one goes that.
Okay, here's how you know. The smallest side is always opposite the smallest angle. The largest side, the hypotenuse, is always opposite the largest angle, which means the middle side is always opposite the middle angle. These are the three measures for their small triangle. Is there anybody in the room that can tell what the angle measures of the other three triangles, or the other two triangles in their group are, without any more help?
I do the same.
Why would they be the same, Josh?
No matter how long the triangle is, the angle stays the same.
Yes. That's one of the things that we had last unit, is that when you have three, what do you call these triangles? Three similar triangles. The angles are the exact same in all three. Check your work. Did it seem like they were? Did you guys get the same? No. Sam, how far off were you?
I'm only one off. It was on these ends. They were one apart.
Okay, and that's entirely, could be the guy that did the cutting. If we could blame it on him. How about you, Jeff? Did you guys get the same for all three of them?
Yeah, pretty close. It's aiming off by one on the other.
Frankie, how about yours? How did your group do? Were they all three about the same?
Yeah, pretty close.
Kara?
Off by 2, but
Off by 2, but it could have been a measuring situation. Okay. Now, next. Since your triangles are all three the same, okay, I want each of the groups to do these three fractions for all three of their triangles. And tell me what those three fractions are for each of your three triangles. A over H, O over H, O over A.
A over H. I know what that means.
This is for the sides, right? Michelle,
What's
this
that?
is for the sides, right?
The sides, right, not the angles.
So we're all.
Oh, do you want me to write? So A, that was A over A. We did A over. Wait, did I just do A over O? I'm going to 214.5. Yeah, you did A over O. So A over O equals
Oh, I didn't, maybe I attended sheet there.
So what else do we need? A over. Equals 3.7
Okay. Yes, Sam.
Don't you want to be that bottom one? Don't you want to be doing O over H and O over A?
Did it? Oh, I'm sorry. This first one should have been A over H. I'm sorry. The first one should have been A over H. Change your first one to A over. Oh.
The bottom one is O over H, because you have A over A.
I want O over H, A over H, O over A is what I want. Sorry.
A over O.
O over A. I want O over A. That one I know is right.
Okay.
It's the other ones. I want H on the bottom for the end. I'm sorry. I screwed you up. O over H, A over H, O over A. Those are the three that I want.
Over H. This has to be
O over A. O over H. O over A.
Okay, what's O over H?
All right.
14.
Let's start with a group that's done. Anybody done with all of theirs? Ashley. Your O over H. What did you have for the small triangle?
0.77.
What did you have for the medium-sized triangle?
0.64.
What did you have for the large triangle?
1.2.
No, you're going the wrong direction. I'm talking about small, medium, and large triangles.
Okay.
Who had the medium triangle?
I did.
What'd you have for O over H?
0.78.
What'd you have for the big triangle? Whoever had that, Gabby?
0.79.
Now we can go through. Then, A over H, what'd you have?
0.64.
0.64?
0.62.
What'd you have? Point what? Okay, then for O over A.
1.2.
1.27.
1.25.
Okay, look at their three measures. What do you notice about those ratios? They should be
The exact same.
the exact same for all three of them. Okay, the TTF group. What'd you have for the small triangle O over H?
0.92.
Medium-sized triangle. 0.92. Large triangle.
0.93.
How about A over H?
Or the same there.
Large. 1.38. 1.75.
Are they doing okay? Seem to be. Large triangle, or O over H.
2.42. 2.4. 2.48.
All right. The TSKN group.
0.25, 0.98, 3.92.
That's your small triangle. Medium-sized triangle.
I said 3.92.
Then I didn't hear what you said. I wrote what I heard. All right. What'd you have for medium?
0.25, 0.96, 3.85.
And then the large triangle.
0.25, 0.97, 3.93.
9.8.
3.
Okay. And then the HJK group. Small.
Over 8 first.
Point what?
0.87. 0.5. 1.7.
Oh, I see. You went this way.
Yeah.
1.7. Medium-sized triangle.
0.7. What? 0.87. 0.49.
Point what?
49. 1.75.
Okay. Large triangle.
0.86. 0.5.
0.5.
Yeah.
And
1.7.
okay. Quality control. There are two numbers up there that are not making sense in my mind. They should be obvious to everybody. No, they aren't, huh? Samantha, you think they are, though. Which ones are they? Where are we? Anybody positive they know where our discrepancies are?
3 and 2.
Right?
0.85.
8.9.
This group is off. Okay? Now, Kara thinks she knows exactly who the problem is, who the problem child is. She is convinced she knows it's not her. Okay? You're convinced it's not you? I don't see anybody taking out their calculator and seeing what they did wrong. Redoing A over H. You, well, okay, who had the 0.85 then? Oh,
I must have screwed up.
so you just, it was just the way it was reported to me. It was, this should have been 0.5. Okay, alright, then that was the only problem. You guys didn't make a mistake, it was just me writing them down wrong. Okay, now, here, these are all, everybody agree, each of these decimals is a ratio, right? It's a ratio of opposite to hypotenuse of the small, opposite to hypotenuse of the medium, opposite to hypotenuse of the large, adjacent to hypotenuse of the small, opposite to hypotenuse or to adjacent of the small, right? Everybody agree with those are all ratios, okay? The title of this unit is Trigonometry. Trigonometry is measuring trigs, measuring triangles. That's what we're doing in this unit, is measuring triangles. Each of these has a name. Does anybody know their names? Sine, cosine, tangent. Those are their three names. They're called trigonometric ratios. Okay? Those are trigonometric ratios of angles. Opposite, hypotenuse, adjacent, opposite, hypotenuse. Tell you what, I'm going to draw the triangle a different way. Adjacent, opposite, hypotenuse. They're all related to the angle. Alright? And the angle they're related to is this one right here between your hypotenuse and your small side. Hold up your triangle. Everybody grab a triangle, hold it up, and point to the angle that we're talking about on your triangle. Hold it in your right hand, the angle that we're talking about. The angle that we're talking about is in your right hand. Everybody clear on that? That is not a triangle.
Part of one.
It would be a triangle if there'd be enough parts, right? Okay, so that's the angle we're talking about. You know the measure of that angle. Okay? You know the measure of that angle. For the HJK group, what is the measure of that angle? How many degrees? 60. For the Tiskin group, what's the measure of that angle? Let me consult my nose, my team. We're gonna have a huddle to figure out what. Okay, there's only 3 questions. 77. Okay.
Yeah.
And for the TTF group, what's that angle?
69.
69. And for the JAG group, what's that angle?
52.
52. Would you please now press on your, make sure your calculator is in degree mode. If it's, look up at the top, it'll say a D. Okay, make sure it's in degree mode and press sine 60, cosine 60, and tangent 60. We're going to write those three down for each group. Sine 60, cosine 60, or sine whatever, cosine whatever, tangent whatever. You're doing your own group, yeah. 60, 77, 69, and 52.
I think just one.
Point nine.
Anybody need help on how to use their calculator?
Oh, I'm an idiot.
Gary, your calculator can do it. Yes, it can.
Already there.
No, come on, it's easy. Just press
Plus
S
two,
when you get it done.
Yeah. Then you gotta retype it.
Sine,
4.3.
sine, 6, or whatever your first one is, 60, equals, and now press S to D. 0.8666. Write that down. We're going to do cosine and then do tangent. Are we ready? Okay, the JAG group. What'd you get for the first one?
0.79,
What'd you get for the second one?
0.62, 1.28,
For the ta-ta for now group.
I'll get 0.93, 0.36, 2.6.
For the Tiskin group,
0.97.
I think we got them in the wrong order, right?
0.97 is fine.
Well, okay, I'll write it down the way you say it.
0.22. 4.33.
For the HJK group,
0.86.
Did we?
actually it's 0.87 if you round it, right? 0.866. Yep.
0.5.
Is
1.7.
clearly.
Now, this group did not have those exact answers. This first one was root of 3 over 2. This one was 1/2. And this one was the root of 3. Those were their three. Check it again. Do the tangent 60. What'd you get?
1.73.
No, before you do
Square root of 3.
square root of 3. These are the exact answers for a 60-degree angle. A 60-degree triangle is one of the special ones. It's a 30, 60, 90 triangle. That's one of the special ones. Another one of the special ones is the 45, 45, 90 triangle. Okay? Now the reason that their triangle worked out the way it did is that I used a piece of particle board that was 24 inches this way. I just made sure that this side was 12 inches for theirs, so it wasn't magic. I mean, I did that on purpose because I wanted one of them to come out to be that angle. Okay, now, quality control. Houston, we have a problem. Which group do we have a problem with?
Tiskin.
I'm looking, yeah, Tiskin. What did you? Something is wrong. Either these are wrong or these are wrong. Now, quality control will tell you which one is wrong. Look at this. 0.87, 0.5. Do you notice how the sine is always bigger than the cosine for all the other groups? Do you see that? Do you see your group? So where do you think the mistake was made? What you reported as opposite over hypotenuse was really adjacent over hypotenuse. Okay? So these numbers here, these three numbers here should have actually been in the second row down. These three numbers here should have been in the top row, okay? Because a smaller angle, look at the 60, 77, well, let's do it this way. arrange these angles in order. 52 is the smallest, right? Then comes 60, then comes 69, then comes 77, right? What happens to the sine as you get a bigger angle? So the 52 has this sine, the 60 has this sine, the 69 has this sine, and the 77 has this sine. Yeah, this sine here. What happens to the sine as you get bigger? The sine, so bigger angle, bigger sine. Smaller angle, smaller sine. Okay, let's go through the cosine. What happens to the cosine as you go from the smallest angle on up? What happens to the cosine? So a big angle has a small cosine, and a small angle has a big cosine, right? Tangent. What happens to the tangent as you get bigger and bigger? As you get bigger and bigger, the tangent gets larger. So a bigger angle has a bigger tangent. A smaller angle has a smaller tangent. Okay? Now, let's write down some rules for quality control. Because these are going to be important as you go through your answers for the rest of the unit. Rule 1. I don't care, we can list them in any order. Come up with some quality control rules. I've told you some of them.
Adjacent angles always small.
Not necessarily.
Or a side.
Hypotenuse is longest side. Now, Josh was right for the way we named our triangles. We named our triangles that the adjacent side was the shortest one. We could have made this the adjacent side. If this is the adjacent side, then this is our angle, and we should have held it with our right hand here. Okay? Opposite. Does it make sense this is opposite the angle that we're holding on to? Everybody agree with that? Okay? So, he's on the right track. The smallest side is opposite the smallest angle. The smallest side is opposite the smallest angle. That's rule 2. Rule 3. Can I make a triangle out of these 3 things?
No.
Do you see a problem here? What has to be true for me to make a triangle?
A plus O is.
Okay. Rule 3 is any 2 sides have to be greater than the third side. Any 2 sides have to add up to something greater than the third side. So, I'm going to give you some choices. 1, 2, 3. 1, 5, 8. 2, 7, 4. 5, 4, 3. Which of these can be triangles? Those are our 3 sides. Which of them can be triangles? 5 is, well, 4 plus 3, that's bigger than 5. 5 and 4 is bigger than 3. right? And 3 and 5 is bigger than 4, so that works. 2, 7, 4. No, because 2 and 4 makes 6, and 6 isn't bigger than 7, so that can't be. 1, 2, 3. Well, 1 and 3 is bigger than 2, right? 2 and 3 is bigger than 1, but 1 and 2 is equal to 3. Here's why it can't be equal, okay? If they exactly equal, can you see what would happen? You know, as they get closer and closer, you would just be having, it wouldn't be a triangle, it'd be a line segment. Okay, how about the next set? Does this work? 1 and 5 and 8? 1 and 5 isn't bigger than 8, right? Okay, so this is the only one that works. Any two sides have to be greater than the third side. Okay, other rules. Rule 4. Sine and cosine are less than 1. Let's think about why that is. They are both ratios, correct? What is true about each of those ratios? Who's on the bottom? Hypotenuse, right? And what's always true about the hypotenuse? It's always big, right? It's always the biggest part. Oops, I didn't make mine. It's always the biggest part, okay? So if you had pizzas, right? And you always had more people than you had number of pizzas, what would be true about how much pizza each person would get? They wouldn't get a whole pizza each, right? If you have more people than pizzas, they wouldn't get a whole pizza each. So the sine and the cosine are always less than 1. Is the tangent always less than 1? No, all you need for the tangent to be bigger than 1 is to have the opposite side bigger than the adjacent side, which was true for all of your triangles, right? Because we always made sure we were talking about the smallest angle, okay? If we would have been talking about a different angle, it would have worked out differently. All right. That is an introduction to what we're doing tomorrow. What we're doing today is just Pythagorean theorem, which is kind of simple. But it's figuring out triangles based on any two sides, and we did that first, okay? That's all you need to do. Before you leave, put your kit back together again so that I can take it down to my office, and we'll see you next time.